Hi everybody, welcome to our next Excel video. So in this one, we're going to work with XY data. So we have pair data, so data in two variables here. And we're going to talk about how to create a scatter plot, how to find the correlation coefficient for linear data, and then assuming that the correlation coefficient actually is significant enough, how to find a equation that would best mirror this data here. So I'm just going to show you a couple quick tricks here. And of course, there's a lot more you can do. So Excel is capable of running a full kind of regression analysis. We're not going to do all of that here. Again, I'm going to show you a couple just quick tips and tricks that you can use to help you answer some of our homework questions and give you kind of a basic idea of how we can do linear or regression in Excel, again, without having to go through a full process. So the first thing I have here is I did already input my data. So I just labeled it X and Y. So I have my X data in the first column and I have my Y data in the second column. And it is important to note that the data is paired together. So you're not just putting these randomly in, it should be sorted as XY data. So for instance, the 1.8 is paired with the 604.4, and the 1.3 is paired with the 434.2, etc. So each of these, for instance, is a point, 1.8, comma, 604.4, etc. So you do want to make sure they are lined up appropriately when you enter your data. All right, so first I'm going to show you how to create a quick scatter plot. And what I need to do here is I'm going to highlight my data sets. And again, it is important that they're paired up because Excel will assume that they go together. So I have my X value in the first column, my Y values in the second column. And I'm going to go up here to Insert. And then there's different things that you can do. I like to typically click recommended charts. And Excel is pretty good about figuring out what you want. And you can see here that the first one that pops up actually is a scatter plot. You can always search through, if you don't see one that you like, or come here to all charts, and then you actually would have the option if you don't see, again, the one that you're looking for. For us here, so again, here's your scatter plot as well there. For us, first recommended chart is a scatter plot. I'm literally just going to click OK, and there's my scatter plot. You can, of course, go in and tweak things. So I'm not going to do all that in this video. If you are interested in learning more about Excel, there's definitely tons of videos online or other courses you can take. But if you click, the plus here and some of these tools on the right, you can play around with the different colors and the axes, etc. Looking at the graph, I do see it does look pretty linear, going in a positive or upward direction. So my next step after graphing, if I think that, hey, I think I do have linear correlation here, is to find the linear correlation coefficient. And Excel can do that very quickly for us. And that is R. So you see that labeled as R. Or they use a Greek letter R, which is a row if you're talking about population data instead. Here we have sample data, so we'll use the English letters. Now, the formula to find this in Excel is CORREL. So it's the beginning part of correlation. So I'm going to hit an equal sign. I'm going to start typing in correlation. And you can see right here, it says it returns the correlation coefficient between two data sets. This is the linear correlation coefficient, by the way. So I'm going to double click this. And then it's telling you to select your data. And you just select it one column at a time. So again, I'm going to select my X column first. I'm going to put a comma, and then I'm going to select my Y column second. And again, you do just have to make sure your data is entered in as pairs so that Excel, again, is recognizing that in the background, what goes with what. So I select the first column, comma, second column. I go ahead and I hit enter. There's my correlation coefficient. So super nice and quick. One more time, CORR, start to type in correlation, and just select your data. So my X values, comma, my Y values. Now, this is a strong correlation coefficient, right? It's very close to 1. And you can actually confirm this even further by using the charts in our text. So I'm not going to go to that piece here in the video, but again, there's a lot more work that you could do here. So we do have tables that we can compare our values to make sure they actually are significant enough. We can also do hypothesis testing as well. So let's assume that this actually is a strong enough correlation, and it is. So that part we can kind of check off our list. How do you actually make the linear equation that would go with this? So our basic linear equation is y equals mx plus b. And m is your slope, and b stands for the y-intercept. Now, sometimes your text may write the formula the other way. So they'll put the b first, like this. So y equals b plus mx, which is fine too. It really doesn't matter. But the slope is the one with the x, and then the other value is your y-intercept. And notice that the other side is a y equals. So that is your general form for a linear equation. Excel can find the slope and the y-intercept for you again very quickly. So the formula for slope is literally slope. So I'm going to go ahead and start typing the word slope. Now, the only thing you have to be really careful about here is if you select your data, it asks for the y values first. So remember when you do the slope formula, it's always the change in y over change in x, or y2 minus y1 over x2 minus x1. So Excel wants it in the same order. So just be careful for that reason, or else everything will be upside down or backwards. So you do have to select your y values first, hit a comma, and then select your x values. I hit enter, and that's it. There's my slope. So again, one more time, I start typing in the word slope. Be careful here, you enter your data backwards, y values first, comma, x values second, and hit enter, and that's it. For the intercept, the formula there is literally called intercept. It is specifically the y-intercept, though. We do have x-intercepts as well. So I'm going to hit equals. I start typing intercept. And again, this also wants the values backwards like the slope does. They want the y values first. So I select my y values, comma, my x values, hit enter, and there is my intercept. All right, one more time. Start with the equal sign, start typing in intercept. And again, this is specifically the y-intercept in reference to a linear equation. So again, we're just focusing on linear here. There are obviously different kinds of correlation if your data shows different shapes. But our focus in this class is just going to be linear. And there's our intercept. So now the last piece is for you to put it together. And again, you can just kind of look at your text to see how they want the order. In more traditional algebra classes, we tend to put it in this way with the mx first. Sometimes in stats books, they like it this way, but it really doesn't matter. At this point, you're just filling in. So our m here is about 199 point, we'll just say 53. So I would put that with the x. And then I would add in my y-intercept, which is about 56.04. So this is correct here. Or again, if you write it the other way, you could put the 56.04 first, and then add it to the 199.53 with the x. The key thing is, though, that when you're in that y equals form, the slope is always with the x, and the other number is your y-intercept. So I hope you found this video helpful. Again, Excel is a lot more robust than this. It can really go into a lot more detail and more analysis here. But for our beginning stats class, this is a very quick way to actually do a lot of the basics that we need. So really quick and easy to actually start with a scatter plot and then find our R value. And then assuming that that actually is significant enough, we can use Excel to quickly find a good equation that matches this.